Okay, I'm continuing with my lectures on Venn diagrams and propositional logic. And my name is, I haven't mentioned it for a while, my name is Richard Hammerud, and I'm giving a complete course in Venn diagrams and symbolic logic. I have taught logic in college for more than 20 years, going over logic and stuff, and I developed the system on my own. So it's a completely new system. Um, no one has no books will do this. They don't do when you study propositional logic in college. You do not do Venn diagrams. So this is a new system I'm doing. Hopefully in the future it'll be in books. It should be. Venn diagrams are used to diagram categorical syllogisms. Everybody does that. Very few people. I don't know anybody that knows how to do this system. I don't know anybody that knows how to do this. It's a system I made up. And so eventually one day, believe me, it will be taught because it works. And if you can picture logical relationships using Venn diagrams, then do it. That's what they're made for. So anyway, let me go over this. This is a truth table here. If you have two statements, P and Q, I'm just going to be using P, Q, and R. But at this point, we're just using P and Q. If you have two statements, P and Q, like today, P could stand for today is Monday, Q, it's raining outside. Okay, it doesn't matter. Just as an example, I'll say I'll abbreviate it. Say I'll put the word raining, just so I have something to talk about, to illustrate it. And today is Monday. Okay. So if I want to say it's raining outside and today is Monday, P and Q, they're both true, then that statement is true when they're both true. The statement is false when one of the statements is false. So in line, there are basically 4 lines here. 1, 2, 3, 4. In lines 2, 3, and 4, there's always going to be one false statement. There's one false statement, one false statement. Here they're both false. The only line of this truth table where P is true and Q is true is line 1, and that is the only line where the statement P and Q is true. So think of it always, when you do truth tables, it always goes this way. You start, if you have 2 letters, the one on the left, you go TTFF, and the one on the right, you go TFTF. It's always the same. There's nothing magical about it. You just memorize it. I mean, you could do it the other way, but actually, it was actually done the other way years ago. But now this is the standard view, the way it's conventionally done. So when you have 2 statements, you're going to have 4 lines, 1, 2, 3, 4, and you go T, T, F, F, T, F, T, F. Meaning, it's think of like if you have 2 pennies, you flip 2 pennies. You're either going to get heads, 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 tails, tails, heads, tails, tails. With 2 pennies, there are 4 possible combinations of heads and tails. With 2 statements, if you kind of metaphorically flip the sentences, there are 4 possible combinations. If I say today is Monday and it's raining outside, well, they can both be true. The first one can be true, second one false. False, true, false, false. That's what truth tables do. They just give you all the possibilities. They give you all the possible combinations, and then the and, P and Q, the rule of the and is that anytime you have a conjunction, this is called a conjunctive statement. This is the left conjunct and the right conjunct. Okay, P is a conjunct and Q is a conjunct. I'll write that out later. But this is called a conjunction. You're conjoining 2 statements. The rule for P and Q, I will box it in. When I do the rule, I'll box it in. So the rule for P and Q is this. What this means is this statement is only true when P is true and Q is true. So I'll write rule. That's the rule. This says exactly what this says, but in a briefer way, because I'll make that better. That's an ampersand, okay? So P and Q is only true That's why I only have one line. It means only true. And when I box it around, put rule. It's P and Q is only true when P is true and Q is true. Now that's what this says up here too, but you have to kind of figure it out because we have the only time P and Q is true, there's only one time, is when up here, line 1. All the other ones, P and Q is false. So basically the rule is P and Q is true only when they're both true. That's what that rule says. And that's what that diagram says. P and Q is true. When? When P is true and Q is true. When we're inside P and inside Q. Remember, one thing that makes this easy to do is just remember that inside P means P is true, and outside P means P is false. So outside P means P is false, but it also means not P is true, because that's the same. You see, because anytime you negate a statement, you switch truth values. So this section here, outside P, means, and it's also outside Q, but I'll just focus on the P right now, means P is false. It also means Q is false too. But not P is true, and not Q is true. Okay, so you just have to know what the sections mean, so once you get used to that, then it's easy. But if, again, as I said, you have the key thing to interpreting these is to go through them systematically. When you look at a diagram, if you just look at it and you don't have a method of how to say it, you will get confused. I guarantee you that. But if you do it systematically, you won't get confused. If you do it if you have an order to, if you do it orderly. So the first thing you do is this: you put your finger on the statement and say it out loud, P and Q, and then you just put your finger on a section. If it's undarkened, then you say P and Q is true because it's undarkened, and then you say when. Don't forget that when, and then you say what that section means. When P is true, because we're inside P, and when Q is true, we're inside Q. And then you say, look, do another one. P and Q is false. Okay, I put my finger on this section. P and Q is false. I said it's false because it's darkened. P and Q is false. Then you say when, and then you just say what that section means. P and Q is false when P is false, because we're outside P, and Q is false. P and Q is false when P is false and Q is true. P and Q is false when P is true, or that's line 2, when P is true and Q is false. The key thing is this diagram here conveys exactly the same information that this diagram conveys. And that's why it works. I mean, that's why it works. Okay, now, so let me give you another example. So that's the rule. P and Q is true. It's only true. That's what, when I give you the rule, it means only. That's the only time it's true. Okay. So let me give you another example here. I'll introduce the or. So let me give you the rule for or. P or Q. Here's the rule. And I'll put right rule. And I box it in. Now, what does that mean? Well, I told you how to read it, so I'll give you a little second. Think about it. Okay, now I'll read it. Do not forget the word only. Read the statement. P or Q. We're not doing the and anymore, right? We're doing the or. P or Q is false, is only false. Because it's the rule. Only false. When P is false and Q is false. Now we can do the diagram. P, Q. And then we're going to do the truth table for P or Q. Okay. And they're going to 4 lines. right? It's always going to be the same. Well, these are you go T, T, F, F. Just do it the same way every time. Then TF, TF. Okay, we got 4 lines. The 4 lines correspond to the 4 lines. The 4 lines of the Venn diagram. Okay. P or Q is true when P is true or Q is true, or they're both true. The only time when P or Q is false is when they're both false, because then neither one is true. So P or Q is only going to be false for line 4, because they're both false. If I say to you today it's raining outside, or today is Monday, if it's not raining outside and today is not Monday, then I was lying to you. But if one of my statements is true, or they're both true, then my statement is true. So this is the truth table for P or Q. Now I'll do the Venn diagram. So P or Q, P or Q. I'll do the false first because there's only one false. So once I get the false, I can just do the opposite. So the rule is here. P or Q is false when they're both false. Well, they're both false for this section here. That's what that section means, false. So I go P or Q is false. I put a darkened section there. I darken it out when P is false and Q is false. Okay, the other ones, it's P or Q is going to be true for all this section, and this section. So P or Q is true for this section when P is true and Q is false. P or Q is true when P is true and Q is true. And P or Q is true, because it's undarkened, when P is false and Q is true. P or Q is false, it's darkened. You say it's false when, and then you just say what the section says. P or Q is false when P is false and Q is false. So that's how you diagram that one. Now, let me show you something interesting, and when you negate a sentence, like let me get rid of this, and let me just show you something. This is really cool, because you don't even have to figure stuff. You don't have to even do any work. This is automatically. But let's say, and I'll explain next time I run out of time, but I'll explain next. I'll go over the Venn diagram, the truth table. But let's say I want to diagram this. We know this is a diagram for P or Q. Now let's say I want to negate that. So now I got to put the parentheses back on because I'm negating the whole sentence. So now I'm gonna diagram this. Now, that could take a little work to do. I mean, if you do all the truth tables, and it would take you a little while to figure out how to do not P or Q. But there's a very simple way to do it, and here's the rule: whenever you have a diagram, of any statement, and then you want to diagram the negation of that statement, it's very easy. You just switch colors. So what's going to happen is that the white ones are going to become dark, and the dark sections are going to become white. So the answer to this one, if this is the diagram for P or Q, and it is, then if I want to do not P or Q, this is going to become undarkened, so I don't darken this. But these don't have any dark circles, so I got to put dark circles. So basically, it's a mirror image. You don't even have to think about it. Now you can do a truth table and see if it works out, but that's what it does. So basically, when you have a statement and then you negate the statement, you just switch colors. Dark becomes white, white becomes dark. Dark becomes white, or dark becomes undarkened, and white becomes dark. Undarkened becomes dark. That's it. So that's the diagram for not P or Q, right there. That's the diagram for P or Q. So anyway, that's all for today. But practice with this, because once you get the idea, it's very simple and it's fun.